Okay, we're looking at 2.5.14. If f is a primitive nth root of unity, then so is s to the negative 1. All right, so first thing I did was show that the order of, the order of s is n, and n is the least natural number, such that s to the n is 1. We want to show that s to the negative 1 is also a primitive. So likewise, order of s to the negative 1 is n. And n is the least integer, such that s to the negative 1 to the n is 1. So really, this is the main part that we're wanting to show. All right, so s to the negative 1 to the n is 1 over s to the n, which is 1 over s to the n, which is 1 over 1. So right here, I'm looking at s to the n. I'm using a substitution from here. All right, which is 1 to 1, which is equal to 1. So then I'm looking here, and I set that equal to this. And that is here. Now, that shows that n could be the least positive integer, such that s to the negative s to the negative 1 to the n is 1, but it doesn't quite prove it all the way. We need to show that n is the least. All right, so this would show that n might be the order. However, we want to show that n is the least integer to actually show it. We will assume that there is a smaller integer, L, such that L is less than n, such that, there we go, 1 over s to the L is 1. So that would mean that 1 over s to the L is 1, which implies that 1 equals s to the L. And this is a proof by contradiction. But s to the L is 1, and so is s to the n. So that means s to the L is s to the n, which implies, I'm looking right here, which implies that L is n. That's a contradiction because L is supposed to be less than n. So n is the least natural number. This implies that the order of the inverse of s is n, and the order of s is n, as we already know, as we already assumed up front, which shows that the order of the inverse of s is the order of s, which is what we're trying to show. So we're done.